Alright, 6.6, numerical integration. We are going to be focusing on two different rules that are another way of approximating area under a curve. They're not necessarily as accurate all the time, but they're just different in ways that we can approximate the area. The first one here is the trapezoidal rule. What we have here is your basic integral here, right here. And what we do between A and B, I'm going to give you an n value in these problems. Okay, and n will be going right there. It's how many different ways we're going to be splitting up the area under the curve. Okay, I might say we go from 0 to 2, and 0 to 2. With that said, with 0 to 2, we have an n equal to 8. Okay, so it'd be 2 minus 0 over 2 times 8. Okay, that's how it would work. And then for each individual f of x, the first and the last one, you just multiply by 1 and add it. The others, you multiply by 2 each individual time. Now, how many times we actually do this depends on what our n value is and what your change of x is. So back to what I was saying before, my vague example, if b and a are 0 to 2, and I said for n equal to 8, so that would mean that the change is for every 1/4, right? So we're going to start at plugging in 0 for f of x, and then it'll be 1/4, and then it'll be 1/2, then it'll be 3/4, then it'll be 1, and we keep going. Okay? It's a pattern. That's what we'll be doing. It all depends on how many we get until we hit our end 2. We'll do some examples so that kind of brings it to light, but it's just following this formula every time. And yes, of course, you'll get it for your test. For this example, we got the integral from 0 to 2 of x cubed dx when n is equal to 4. Okay, so what's the change here from 0 to 2? The change would be 1/2. How do we know that? Because if you take 2, I'm getting my pointer here, 2 minus 0 divided by 4, that's going to give us a change of 1/2. So the change in x is equal to 1/2. That'll be important for when we go to solve. Now I'm going to write this part, but you don't have to write this part unless you want to take thorough notes so you understand it later, which might be a good move. So remember our formula says b minus a over 2n, right? I said n is 4 and b is 2 and a is 0. So it would be 2 over 8 for the first part of the equation. Then what's inside the parentheses? We're going to be finding f of 0, because that's where we start with our a, plus 2 times f of 1/2, plus 2 times f of 1, plus 2 times f of 3/2, plus, remember, it's just going to be f of 2. We don't multiply by 2 that time. So 2 over 8 reduces down to 1/4. F of 0 gets a 0, plus 1/2 to the third power times 2 will get us 1/2 to the third is 1/8 times 2 is going to get us 1/4, plus, put 1 in, we're going to get 1, times 2, we're going to get 2, plus 3/2, 3/2 will get us 27 over 8, 27 over 8 times 2 will get us 27 over 4, plus f of 2, we put 2 in, you're going to get 8. Add them up. What's the inside add up to? That'll get us 17. 1/4 times 17 will get us 17 over 4. And there's your solution. Alright, so the last formula is called Simpson's rule. Okay, so we have the same integral from a to b of f of x dx. Small change here. You get b minus a divided by 3n. And also, instead of having 2's, you're going to have all 4's, and then, oh, I'm sorry. This should be a 2 right here. So go ahead and pause it and copy this down. It'll keep alternating from 4 to 2 back and forth. 4, 2, 4, 2. And then the last one will end up being 4 and then nothing again. Okay, so we'll do an example. We'll do the same one as the last one except using Simpson's rule. Alright, so same integral. So let's set this up. So it's b minus a, which is going to be 2 minus 0 over 3 times n. So it's going to be 12. And on the inside, I'm going to set it up similarly. Once again, the change is 1/2 because 2 minus 0 divided by 4 is 1/2. So that's a change. So every 1/2 you're going to be doing this. So 4 of f of 1/2 plus 2 f of 1 plus 4 f of 3/2 plus f of 2. Put 0 in and get 0. 1/2. Get 1/8. 1/8 times 4 is 1/2. Put 1 in, get 1. Times 2 is going to be 2. 3/2 to the third is going to be 27 over 8. Times 4 is 27 over 2. I'm going to make that 1 over 6 and just reduce it right there. F of 2 is simply going to be 8. Add them up, you're going to get 10 plus 14 is 24. 24 times 1/6 is going to be 4. Okay, now, what I would like you to do is pause this video and try to find the integral from 0 to 2 of x cubed dx by doing what we've been doing the past week or so. Okay, so go ahead and pause it, find a definite integral, tell me what you get. Hopefully when you did this, you would have got 4. Okay? Sometimes this works out, sometimes it doesn't. Okay? It's not going to be perfectly accurate because you saw in the last method with trapezoidal rule, you got 4.25. Okay? So doing this method of approximation sometimes works out, sometimes doesn't, and will get us sometimes slightly off, but somewhat in the ballpark still. I appreciate you watching, and we'll see you in class. Bye-bye now.